Hello guys, welcome to this lecture, and this lecture is on loops. I think in the previous video we stopped with finding no implementation of leap year. We saw a big story, and from the story we took a condition, and that condition we converted into a program, right? Fine. So now what we will be doing in this video is we'll be seeing about loops. Loops are also called as repeating statements, as well as they are also called as iterative statements. We have three types of loops: while, do while, and for. Before getting into these loops, first of all, we will find out the reason why we want loop, when we want to go for loop. Okay, so for example, I will just take you the scenario of converting a decimal number to binary, which I have shown you already in the video one. If you want to go to part one video, and you can see that conversion. For example, I will again tell you, if for example, if I'm taking a number called 12, I can divide this 12 by 2. If I divide this 12 by 2, I get a quotient of 6, and a reminder that we will get is 0, because it is completely divisible by 2, so no reminder will be there. So again divide 6 by 2, again it is completely divisible, so you will get a 0 reminder, and the quotient will be 3. When you divide 3 by 2, 3 is not divisible by 2, so it will give you a reminder of 1, and the quotient is also 1. Now again divide your 1 by 2, you get quotient 0, and your reminder becomes 1. Okay, fine. So now if you just look at this, the corresponding binary representation is actually the reverse of the reminders. So what's the reverse of the reminders? Actually 1100 is a 4-bit binary representation of the given number called 12. But why I'm illustrating this is that I think we are doing process. What process we are doing is, instruction is, we are taking a number called n, and we are dividing that n by 2. We record the remainder. Again we divide it by 2, we find the remainder. Again divide by 2, find the remainder. The procedure is same. Every time what we are doing is we are dividing the n number by 2, and we are recording the remainder, as well as we are also taking the quotient and changing n to the quotient. So when the same process, divided by 2, divided by 2, divided by 2, divided by 2. So division by 2 is a process which is repeated not for one time, but for up to what? Up to when my n becomes 0. Until my n becomes 0, this process is repeatedly being carried out. So when the same step is repeated for more than one time, okay, if you do not know how many times this is going to be done, then you can go with loops. So when you have a repeated process, then you can come with looping process. You can come for loops. So first of all, what I will do is that I'll just take I'll just show you the general structure of a loop. First of all, we will take while loop. And in this I'll just show you the general format of while loop. General format is, you will have a keyword called while, followed by a parenthesis. Inside this parenthesis you have to give a condition. And already in the previous videos I have already taught you how to write a condition. Using relational operator, you write a condition, and suppose if 2 or more conditions coming, then you have to combine those conditions by using you have to compound the condition by using logical operators, and therefore it is called as compound conditional operator. So while of condition, and followed by a body of the loop, and inside the body of the loop you write some process. Okay, so what will happen is that it will enter this while loop. It will check for this condition. If this condition is true, it will check the condition, and if it is true, then it will come to the body part and execute the process. Okay, condition is checked. If the condition is true, the process is carried out. Again it goes back to condition section, again it's checked. When it is true, it go again to the process, again repeat cyclic process. When the condition is false, then it stops and comes out of this block. Fine. I'll just show you also. See, we will see a few problems to understand what is while loop, everything, but I'm just showing you the structure only. Next we will see the structure of do while loop. Okay, first of all, you will have a keyword called do, followed by a block. Inside this block you will write a process, and followed by this do block. Outside the do block you write a while keyword followed by a parenthesis, inside which you have to write a condition. So what is the difference between these things? What is the difference between, see, the semicolon is very important here. After while loop we are not giving any semicolon, but here after while loop we are giving semicolon, because while is, this while condition is the end of this entire do while block. So whenever end of some block I need to mention this is the end of the block. Yes, fine. So what's the difference between these two loops? Both are actually similar, both will do the same process, except for only one situation. On all other situation these two loops are going to do the same process. That I will just I'll just illustrate some example for this, and I'll show you the difference between while and do while. Yes, fine. So now the next thing that what I have to do is we will take an example, and then we'll at last we will come to for loop. First of all we'll finish this while and do while, and then we will get into for loop. Okay, so we will see few examples of to illustrate looping. First of all, let me take n value. For example, n value is 10. We will consider n value is 10. If n value is 10, what we need to do is we need to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whenever n value is given, you have to start from 1 and you have to print up to 10. Okay, I think this is a repeated process, because printing one number is okay, but printing multiple numbers, that also I know finite number of times, 10 number of times I need to print. So then what I can do, I can use a loop for this. But one more thing, that if you see, I think these numbers are incrementing by 1, 2, 3, 4. I think this is like counting 1, 2, 3, 4, 5. This is like counting. I told you already in the previous video, when we are seeing increment or decrement operator, we have to use increment operator like this when we want to count something. When we want to increment something by just one value every time, then I told you that we can go with increment operator. So this is also will be used here. So first of all, what I will do is I'll just take a variable called I, and I will start it with 1, because your process has to initiate it. Your process has to be started with 1. So that is why I'm taking this variable called I and initiating it to 1. What is this I for? This I is for controlling the loop. So this I can be called as control variable. So this I is just for the controlling of the loop. Okay, fine. So after initiating I is equal to 1, so and also we will take variable called n and assign it to 10. So now what we can do is, the general format of while loop is write a keyword called while and followed by condition. What condition we can write? Up to when this loop has to actually go. Actually, if my I will just take my I equal to 1, and I can start incrementing my I by 1 every time. So I becomes 2, I becomes 3, I becomes 4, I becomes 5. So I start printing I every time. So until when I can print it? Until it reaches n. If I is equal to 1, I is equal to 10, then it is fine. But if it's I is equal to 11, then I will stop the process. So what I can say you is that if I is less than or equal to n, then it is fine. We can keep on printing. But once it exceeds n, then we can stop the process. That is how we give the condition here. So while I is less than or equal to n, what I need to do? Every time I need to print the current I value, which is 1 now, right? So first of all, what I will do is I'll just make a printf statement, %d space comma I. So we will print I. Then after printing this statement, if you see, what is the other process? Because I should not keep 1 itself. I should start moving itself to 2, 3, 4, 5, 6 every time after printing it. So how to increment 1 to 2? We have an incrementation operator called plus plus. So use I plus plus. Use I plus plus or use plus plus I, because I told you that post increment or pre increment is not going to be different when you are using it in an independent line like this. It's not going to make any changes, any difference. Both are going to do the same process only. So I'm doing I plus plus. Okay, so now what we will do is just we will compile and check whether this is working or not. So we're compiling the file, and after compiling we'll just go for execution. Yes, compiled, so we'll go for execution. Yes, it is printing from 1 to 10 perfectly. Suppose if we change the value of n, what will happen? I'm changing it to 15. What will happen? From 1 to 15 it will print. The loop will print it for 1 to 15. If the same process has to be again and again repeated, now we are going for loop. This is a very simple illustration I want to show for the beginners who are coming into programming. Okay. So next what we will see is I'll show you the general format of for loop, and I'll just convert the same thing into for loop also. You might understand bit different between while and for loop. Then I will come to the illustration of difference between while and do while. If you see the general format of a for loop, for keyword will be there and followed by a parenthesis. Inside this parenthesis you have three part. What is the first part? First part is initialization, and the second part is condition part, and the third part is updation part, and followed by a body part, open curly braces, close curly braces, inside which we have to do the process. Yes. So for example, what is this initialization, what is this condition, what is this updation? We can see this while loop. Actually, before starting this while loop, I think we are giving some starting point, initial point of the process. And here inside this while loop, what we give a condition. What is this condition? This is where to start the process and this is where to end the process. Okay, initialization means where to start, condition means where to stop. And now here what we are doing, we are changing the value, control by variable. So what we are doing, we are updating the value, updation is happening. So we are updating the value of I. So all these three things are given separately in the while loop part. We are manually giving it in the different places. Outside the while loop we are giving initialization, in this part we are giving condition, inside the body part we are giving the updation. So what they did is they took all these three things and they wanted to do it inside a same loop called for. So for, what's the first thing? You can initialize something here itself. What you can do, int I is equal to 0. See, there are two ways. What you can do is outside the loop itself, okay, outside the loop itself you can declare the variable and you can initialize that variable here in the loop. Or otherwise, even you can declare here, you can declare and initialize here in this part itself. I'll just tell you, if you declare and initialize in this part, what will be happening, but now I will just take this one. So I'm declaring outside and initializing I is equal to 0 here. So I equal to 0. Then what is the condition you have given? I less than or equal to n. I less than or equal to n. And what is the third part? Updation, which is inside here. I plus plus. So I'm going to give I plus plus. So inside this body part, in the body part, what you have done, you have just printed the value of I. So let me take the same one, just let me write. So now if you see, this while loop and this for loop, both are telling me the same. Both are going to do the same. So for example, what we will do is, to differentiate these two loops, I will just print a new line in between. I'll just print a new line in between and we will just proceed with this. We'll just compile and check whether both these loops are doing the same process or not. Yes, both these loops are doing the same process. Yes, because see here one mistake that we have done is we have not initialized the value of I to anything. So this while loop is automatically taking it as 0 and it is processing. But what we will do is we will just start it with 1 like we did it previously. So here also what we will do, not from 0, we will start it from 1. And already we have proven that both the loops are doing the same, but we will see it now also. Yes, both the loops are doing the same process. So while loop, for loop, do while loop are meant for the same purpose only. It does not mean that while loop can be used in certain situation, for loop cannot be used in certain condition, or for loop can be used in certain situation and while loop cannot be used in certain. No such restriction. Any process can be executed using any of these three loops. It is possible to execute the same process in all the three loops. But for the readability, for the readability only, what we will be doing, we will be choosing certain loop from the list, either while or do while or for, but using any loop we can perform the process. If you see, comparing this while loop, this for loop is very readable, because the initialization part, condition part, updation part, it is, they are taking it in the here itself. Okay, they're combining all these three parts together and it is completely readable now. When a person sees this, he is able to see where the process is starting, where the process is ending, what is the speed in which the process is happening, speed, updation, how the updation is happening. All these three things are visible in the same place itself. But coming to while loop, you have to search. If the body part is very big, then you have to search. If the program is very big, then you have to search the entire code. Then you have to find where it is starting, where it is ending, and where it is, what is the updation. So for loop becomes a little, code complexity is actually very efficient here coming to the for loop. Okay, fine. So now the next thing that what we will be doing is, so for loop can be called also as counter controlled loop. It's counter controlled loop because incrementation, updation is happening inside in the for argument part itself, right? So this can be also called as counter controlled loop. Okay, this can be also called as counter controlled loop. Fine. So next what we will be doing is, we are going to see a small bit of problem like, okay, problem kind of thing. What we will be seeing is, we will be seeing a multiplication table. We will just create a multiplication table. What we need to do to calculate a multiplication table, first of all, to make you understand how to start writing a loop, I'll just show you few ways. Okay, first of all, you cannot directly go on code. You have to do a pen and paper work. How you are going to do the pen and paper work? For example, if n is equal to 6, if n is equal to 6, what I will be doing, okay, what I will just do, okay, for example, you can just take these so first of all, what I'm going to do is that, let me take a column called n and let me take a variable called I. This I becomes a control variable. So if n is 6 and I has to start from somewhere, I will start from 1, for example. Okay, we will write the table first of all, then we will decide where it starts, where it ends. Okay, so it's like 6 multiplied by 1, 6 multiplied by 1, then the answer is 6. Then it is 6 multiplied by 2, then it is, answer is 12, and it is 6 multiplied by 3, it is equal to 18. Similarly, it is 6 multiplied by 4, it is 24. Then it is 6 multiplied by 5, it is equal to 30. And it is 6 multiplied by 6 to get 36. Then it is 6 multiplied by 7 to get 42. Then it is 6 multiplied by 8 to get 48. It is 6 multiplied by 9 to give 56. And it's not 56, 54. And it is 6 multiplied by 10 to give 60. Okay, fine. So I think we can just center out these things. Yeah, fine. So this is what the table is all about, multiplication table. So how many times we are doing it? 10 times we are doing it. So your I is starting, your loop variable is starting from 1 and it is going up to 10. So you clearly, from this visualization, it is clear that the initialization point should be 1 and the end point should be I less than or equal to 10. Up to 10 you can proceed. And how we can write is n multiplied by I. N is a constant value which we have already taken as 6. So shall we just convert this multiplication table into a loop? We will just do this in the 3 loops also. First of all, we will do it in for loop. Then we will go for while and do while also. So in the for loop, what we will be doing is, first of all, I told you one thing, like for int I, directly here also you can declare and initialize. That is what I told you, right? I'll just tell you what will happen if you do like this. Okay, and this is not possible in the old versions of C actually. But now in the modern compilers, this way of initializing, declaring the variable inside a for loop is possible nowadays. So I is less than or equal to n. We saw here itself, here in the Excel sheet itself, we have seen that the process has to go up to 10. So your I is starting from 1, it is coming up to n and I plus plus. See, I will not prefer you to write take I every time. You can take a variable name which will, you know, which will be meaningful. Okay, you take you give a name to the loop variable, something meaningful. Okay, so before starting this, we have to take n value as 6. We will just take n value as 6. So now what you have to do inside this loop is, see, starting, ending, and also every time if you see this I is incremented by 1. That is why in the updation part we are keeping it as I plus plus. So now inside this loop, what we will be doing is, we are going to print in the same order. What order? 6 multiplied by 1 equal to 6. In that order we will be printing format. Okay, so write printf, and what I'll do is %d instead of n %d, then multiplied by, so I'm doing a cross symbol, then multiplied by d. So n multiplied by I is equal to the resultant answer. So %d multiplied by %d is equal to %d. So comma, what is instead of first %d, I need to give the variable what it is, n actually. So instead of first %d, n, comma, instead of second one, n multiplied by I. So second one value is going to be I. What is the third value? The multiplied value. So the third value has to be n multiplied by, here in the printf statement itself you can do the operation also. Here itself you can do the operation also. So semicolon. Yes. Is there anything else I need to do? I think every time it has to be printed in a new line. There comes a escape sequence called /n. See, still we have not seen about the formatting options available using printf, and we have not seen detailed about scanf and all. Okay, that I will just specially, you know, I will spend one session for those things and all about you know, teaching you about the format specifier, escape sequences. I'll spend one more video for that. So now here it is /n. What /n will do is, /n means escape sequence for new line. So when it sees /n, automatically your printf will print a new line, and when the next process is coming, it will be printed in a new line. Okay, so just let me save it, and we will just execute and check whether this is working or not. Yes, it is coming up to only n6. So it is not I less than or equal to n. It is not n means it will come up to 6 only. What we have to do, we have to we have to give it up to 10. So the multiplication has to occur up to 10. So again, now again we will compile and just we will again check. Yes, now it is happening from 1 and to 10. We are printing the multiplication table. And if you change the n value, automatically 7 table or 8 table or 9 table, any table if you want, you can change the n value and you can go ahead with the process. Yes, now it is happening with 7. So 7 table. Fine. So now what we will do is, we will rewrite the same using a while loop. So what we can do, we will just change it to while loop. What we have to do, while loop means initialization part we have to write outside the while loop. So int I is equal to starting point is 1, that you have to give outside. So now coming here, while of condition is I less than or equal to 10. Condition you have to give here. Now updation has to be given inside the loop. After printing only I'm going to do, after doing the process only, always I will do the updation. So first of all, process. What is the process? I have to print. What I have to print? %d across %d is equal to %d followed by a new line for every line. Okay, so here instead of first %d n, second %d I, third %d n multiplied by I. So every time what I have to do, I have to just increment my I value by 1. Here comes the updation. So in the for loop we were giving initialization, condition, updation in the inside the parenthesis itself, but now we are just splitting initialization, condition, and updation, and we are giving in 3 places. One outside the loop, one in the parenthesis part, and one is inside the body part. Okay, and still now we have not initialized n value, it seems. So we will just initialize n is equal to 6 similarly. Okay, so now just again we will just go for the compilation process of, okay, so we will just again let me compile it and execute it. Yes, the same process is only happening. So for the same process, you can also go with for loop, you also can go with the while loop. Now I'll just demonstrate the same process using do while. So now nothing I'm going to change, only this part. I'll just convert this part into do, and I'll write the while here. I'll write the while after do. In the while condition, what is the same condition? I'm just taking, see, let me see, show you what I'm doing is just I'll just copy it, and I will just change it to do loop, do body, and now I'll just change, place this while condition here with semicolon. What will happen? First of all, without checking for any condition, it will directly enter the loop and it will print n multiplied by 1, 6 multiplied by 1. Then it will check, it will increment I, then it will check. Then again I'll go execute, increment, check. I'll go, I'll increment, I'll check. So instead of checking the condition and doing the process, we are doing the process and we are checking the condition. That is the only change. And this is not going to affect in this situation, that will not affect anything, the same process only will happen. Okay, okay, the same process only will happen. I'll show you the difference when it will be same process, nothing extra is printed, nothing shortage also, we are not short of anything. Okay, so now I'll just show you the difference when the difference will be there. Okay, for example, I'll just write a while loop. I'll just write a while loop, and I'll just tell you that I is less than or equal to 10. And if I is less than or equal to 10, what you will do is I'll just print f that this is executed, this is execute, this is executed. And what is it actually? This is a while loop, this is executed. Yes, now coming to your and also I will just write the updation here also, I plus plus. And now the same process I will write, the same process. Let me copy this process and just I'll paste it here. I think both are same, except that here condition is given in condition is given first, body comes next, but here body comes first, then comes the condition. Both are the same, but now I will be changing my value to 11. I'll be changing the value to 11. Now if you see, this will check whether I is less than or equal to 10. Yeah, no, I is greater than 10. So this loop will not even it will not even enter into the body part, because outside the body part itself we are checking for condition. So this will not enter inside and this will not print. So instead of here we will write that this is a do while loop. Okay, so now, but if you come here, first of all, body part will be executed, then only it will check for the condition. So body part is executed means yes, this is executed, do while loop is executed, and then after executing it for one time, then only this while loop will check for the condition, and then it will stop the process. This is the only difference, only for the initial condition. Suppose even if the initial it's an initial condition, if is itself failed, then while loop will not execute it for any time, only not even for one time. But if the initial condition is itself wrong, but do while loop will at least execute this for only one time. This is what the difference, there comes the difference. So if you execute the same thing, you can able to see that this is executed do while loop, but while loop is not executed. While loop is not executed, but do while loop is executed. So do while loop will at least execute for one time, but while loop can have some situation. What happen if the initial condition itself falls, then this will not even execute for one time, but this will definitely execute for at least one time, even if the initial condition is itself failed. This is where the difference between while and do while is coming.